Good afternoon, all of you. Please mark your attendance. Turn on your video. Okay. So some of you send your notes. Jiva, Payal, Joanna, Justice, and Joy. These people sent your notes. Delvin also write, isn't it? Delvin.
Good morning. Good afternoon, Miss.
Good afternoon. Then all others need to send your notes before the next class itself. After that, you want to write your
video na kya clear?
Okay. After that, you want to write your exercises, the descriptive question answers only. Only the descriptive question answers of the exercise also should be write in your notebook. But I give some more time to write that exercise because today I sent that note. So tomorrow evening, till tomorrow evening, you have time to write the exercise question answers. Okay. The other notes you should be sent in before the next class. Those who didn't send before the next class about the questions from acid, bases, and salts, I will report your name. So now I call the name Jiva, Payal, Joanna, Justice, Joel, and Delphi. Only these 6 persons only send me the notes. Okay, remaining all of you should send today evening itself. Okay, Joel of what? Yes, I call you. Then now we can move to our next chapter, that is our 6th lesson. Exercise question answer should be write in your notebook and study well. Descriptive question answers. Okay, all that we discussed in that lesson. Then our 6th chapter. What's its name?
Physical and chemical changes.
Yeah, physical and chemical changes. So, what do you know about physical and chemical changes?
Rusting.
Rusting? Rusting of iron. Is it a physical or a chemical change?
Chemical change.
Okay, it is a chemical change. Then, what about some other changes? You know about milk turns to curd, isn't it?
Yes, ma'am.
There
Yes.
are certain other changes like that. So in our life, daily life, there are certain changes that happen. So some of them are physical and some of them are chemical. Physical change, which means the changing. You know what about a physical appearance? Physical means what we see or what exactly what we see. Okay. So when a physical change, which means when a change in a size or a change in shape or a change in its constituent or what any state of a substance, either liquid to solid or solid to gas, like that. So that changes. Change in a state or shape or size like that is called a physical change. Then what about chemical change? Chemical change, which means there is a chemistry that is which involves some reactions. Okay, there is some reaction that happened, the change of one substance from another. So a new product will be formed after a chemical change. Okay, then a physical change, which means it is reversible, it can be reversible. When I take a paper, when I take a piece of paper, this is a rough paper. When I take a piece of, this is a shape, there is a square shape, this paper has, isn't it? When I fold this or fold like this, what shape change, isn't it? Is there any change in the property of this paper?
No.
No, there is no change in the property, the presence in the number of molecules or any other property. Property does not be changed, but what its shape change, its size change, isn't it? It does not form to or neither convert to a new product. The paper is itself, but it only its size and shape like that change. So we can say that it is a physical change, isn't it? Okay, then we can say it is a reversible process. How we can say it is a reversible process? We can regain its original shape, isn't it? When we stretch a rubber band, what will happen? Its shape change, isn't it? We can make into different, or we can fold it into different shapes. But after we remove the stretching, it will regain its original shape, isn't it? So we can say that it is a reversible process. So these are the main changes that occur in nature, that is physical and chemical changes. So take page number 58. No, 58. Ah, yes, 58. Page number
58.
58. Okay. So please listen the introduction. Just I will read that introduction. Every day you come across many changes in your surroundings. These changes may involve one or more substances. For example, your mother may ask you to dissolve sugar in water to make a cold drink. So there is a change occur. Sugar, when mixed with water, there is a solution. There is a diluted solution will be formed. So there is a change in the concentration, or there is a change in the taste, like that, isn't it? So there is a change of course. Like making a sugar solution is a change. Similarly, setting curd from milk is a change. Sometimes milk becomes sour. So souring of the milk is a change. Then stretched rubber band also represents a change. So we know that all these are the changes. Then make a list of 10 changes you have noticed around you. Can you tell me any other changes that you know or you have noticed? Any other rusting of iron that I just told earlier? Then anything else? Any other changes?
Water
Yeah, water turns to ice.
and gas.
Yeah, or it forms water vapor or gas, isn't it? When we heat or boil, it forms water vapor. All these are the changes. Then, in this chapter, we shall perform some activities and study the nature of these changes. Broadly, these changes are of two kinds. They are physical and chemical change. Okay, then there are several activities about showing explaining about the physical changes given there. Activity 6.1, cut a piece of paper in 4 square pieces. Before that, I will show you the video and we can come to these points along with that video. Okay, then it will be more clear.
മിസ് ഈ പൂപ്പല് പിടിക്കുന്നത് കെമിക്കൽ ചേഞ്ച് ആണ്.
പൂപ്പല്
ഈ പൂപ്പല് പിടിക്കുന്നത് എങ്ങനത്തെ ചേഞ്ചാ?
Yes, it is type of a chemical change. You can see in the bread and other food items, isn't it? Okay. So in this chapter, we are discussing about these changes, different types of change. That is mainly I told you about physical and chemical change. Then the other one, rusting and its prevention, rusting of iron, crystallization. These are the main topics. Okay.
Physical change. A substance is usually identified by its physical properties, by its shape, size, color, state, etc. We know that water is wet and gold is shiny. That is how we identify them. When there is a change in any of the physical properties of a substance, its shape, size, color, or state changes. This type of change is called a physical change. No new substance is formed in this type of change. It is
So in a physical change, what will happen? During a physical change, only the size or shape or state of a substance will be changed, and it is a reversible process, and no new products will be formed. That we know. New products will not be formed during this process.
Is usually reversible.
Take a piece of paper and crumple it. What happens to the paper? The original shape of the paper changes because you have changed the body of the substance without changing its composition. You have only changed the appearance but not the composition of the paper. So, you have not made a chemical change but a physical change. Take
Vimeo has become part of Mighty Oak's everyday processes. We are using Vimeo links on our website to showcase.
Take chalk and crush a small piece of chalk into dust. Add a little water to the dust to make a paste.
This is the activity 6.2 given in your textbook. Please listen carefully. The first activity, that is activity 6.1, cut a piece of paper in 4 square pieces. You can see the figure there. Cut each square piece further into 4 square pieces. Lay these pieces on the floor or a table so that the pieces acquire the shape of the original piece of paper. Obviously, you cannot join the pieces back to make the original piece. But is there a change in the property of the paper? What's your answer?
No.
No, there is no change in the property of the paper. There is only a physical change occur, isn't it? So you can write there, no. That's your observation. So when we cut the paper into different pieces, their shape and their molecular constituents may be changed, but the property cannot be changed. Then activity 6.2. Collect the chalk dust lying on the floor near the chalkboard in your classroom, or crush a small piece of chalk into dust. Add a little water to the dust to make a paste. Roll it into shape of a piece of chalk. Then let it dry. Did you recover the chalk from the dust? What is your opinion? What is your assumption about that? When we break a chalk into pieces and form it into a dust, after pouring water and make again, re-again, when we make into a chalk, does it reform its shape?
No, it is not possible.
No.
Possible. And we can see video.
Roll it into the shape of a piece of chalk. Let it dry.
Is it possible?
Possible.
Yes.
Yes.
Because what? We made a chalk from this dust itself, isn't it? So when we crush this dust or when we crush this chalk and then we again we can make it into another piece of chalk. That is a simple thing, no? Then how we say that it is not possible?
മിസ്സേ ഞാൻ വിചാരിച്ചറിയോ വേറെ ഏതൊക്കെ പൊടികൾ എന്റെ കൂടത്തിലോട്ട് ഇട്ടിട്ട് വേർതിരിക്കാൻ അങ്ങനെ ഞാൻ വിചാരിച്ച.
No. Just collect a chalk dust.
പൊടി തന്നെയല്ലേ?
ചോക്ക് പൊടി ആ പൗഡറിൽ നിന്നാണ് നമ്മളത് ഉണ്ടാക്കിയെടുത്തത്. അപ്പൊ വീണ്ടും അത് തന്നെ ക്രഷ് ചെയ്തിട്ട് നമ്മള് വാട്ടർ ഒഴിച്ച് വീണ്ടും കുഴച്ചതുപോലെ തന്നെ ഉണ്ടാക്കാനായിട്ട് പാടില്ലേ? Yes, so we can make it again.
Did you recover chalk from the dust?
Yes.
Yes.
Can write the answer.
You will
Yes.
obtain the chalk. This kind of change is a physical change. Take some ice in a glass or
So
plastic
we
tumbler.
can say that it is a reversible process, isn't it? So thus it is a reversible and what? It is a physical change.
Melt a small portion of ice by placing the tumbler in the sun. You have now
Then this is the activity 6.3. Then take some ice in a glass or plastic tumbler. Melt a small portion of ice by placing the tumbler in the sun. You have now a mixture of ice and water. Now place the tumbler in a freezing mixture. Ice plus common salt. Then does the water become solid ice once again? What's your opinion?
Yes.
Yes. Let's see.
a mixture of ice and water. Now, place the tumbler in a freezing mixture, ice plus common salt. Does the water become solid ice once again? Yes. Water changes to ice on cooling in freezer.
No, who said that? No. So,
അല്ലല്ല ഞാൻ
first-
വിചാരിച്ചു
വെള്ളമല്ലേടാ
ഞാൻ വിചാ
അതെ
അ-
വെള്ളമല്ല.
അല്ല ഞാൻ വിചാരിച്ചു ഉപ്പൊക്കെ ഇട്ട് കഴിയുമ്പോഴത്തേക്ക് ഇത് എന്തായാലും കുറെ കെമിക്കലൊക്കെ ഉപ്പൊക്കെ ഇടുന്നല്ലേ, അപ്പൊ ഞാൻ വിചാരിച്ചു എന്തായാലും ഇത് ആവൂലായിരിക്കും.
no, it is just to freeze.
അങ്ങനെ വെള്ളം
We did not obtain the solid, exact solid as at the first step. നമ്മള് വെള്ളവും സാധാരണ ഫ്രീസറിൽ എടുക്കുന്ന ഐസ് ക്യൂബ് പോലെയുള്ള ആ ഒരു ഇത് കിട്ടില്ല. എന്നാൽ പോലും എന്താണ് ഒരു ഐസ് ക്യൂബ് നമുക്ക് ഒപ്റ്റെയിൻ ചെയ്യും. Because it contains water and then we can freeze it.
Take some ice cubes out of the freezer and put them in a beaker. Leave the beaker for some time. What would you observe? The ice would turn into water. That is, the state of the matter would change. You want to inhale steam. As you have a cold, you would still have the remaining half measure of water. Pour the remaining water into a suitable vessel and put it on a lighted gas stove. The water would start turning into steam. That is, the state of the matter would change again. Thus, you would
So here we can see that the state of matter, different state of matter, that is different state of water. If the matter
Price
is
have changed.
water, and when at first what will happen, the solid changes into liquid. After that, when we heat, it changes into its vapors. That is, the water vapor will be formed. That is, the liquid state converted to the gaseous state. That is, there is a change in its state, which means it is a physical change.
the state of water only to find that it was a physical change and hence reversible.
Understanding chemical change. A chemical change is a
Okay, so all these are the examples that given about to understand about what a physical change. Then please listen, textbook page number 59. Activity 6.5. Hold a used hacksaw blade with a pair of tongues. Keep the tip of the free end of the blade on the gas stove. Wait for a few minutes. Does the color of the tip of the blade changes? Do you feel, can you assume any change?
change. It will be change.
It will be changed. When we heat an hacksaw blade for some time or for a long time, what will happen? It will change. Then, does the color of the tip of the blade change? Yes, you can write there. Yes. Then, remove the blade from the flame. Observe the tip once again after some time. Does it get back its original color? Do you feel?
No, miss.
No, it cannot back to its original color. In activity 6 so this is the final. Here in this paragraph, we are discussing the observation of all these activities. In activity 6.1 and 6.2 above, you saw that paper and a piece of chalk underwent changes in size. In activity 6.3 and 6.4, water changed its state from solid to liquid or from gas to liquid. And in activity 6.5, the hacksaw blade changed color on heating. So we can say that properties such as shape, size, color, and state of a substance are called its physical property. So these are the physical properties, and the substance which undergo these changes are called physical changes. A change in which a substance undergo a change in its shape, that is like its physical property, is called a physical change. So underline these sentences. It is very important. What is a physical change? Please read it. The last paragraph. Properties such as, and underline it. Properties such as shape, size, color, and state of a substance. Such properties are called what?
Physical properties.
Yeah, physical properties. And the change in which the substance undergoes such properties are called physical change. And we can say the physical change is a reversible one. In such a change, no new substance is formed. During a chemical change, a new product will be formed, but in case of a physical change, there will not be any new substance formed. Okay, you understand? Okay. Then now we are moving to discuss about the chemical change. Then, did you have any doubt in physical changes?
No, miss, no doubt in.
Okay, then we can see how chemical changes occur.
Process in which substantial chemical change. A chemical change is a process in which substances are changed. Chemical change occurs whenever compounds are either formed or decomposed. During a chemical change, a chemical reaction takes place. A chemical change is permanent and is therefore irreversible. For example, burning a log of wood. It turns into ash, and the resultant ash cannot be changed back into log of wood.
Okay, is this understood? That is, a chemical change cannot be irreversible. During a chemical change, we get another form of product, isn't it? Not that product, the another form of that product, another form of that reaction, and it will be our product. So we know that when this firewood wood burns, what will happen? It will react with the oxygen, atmospheric air or oxygen, and it convert to the ash. And we cannot reverse this ash to wood. Okay.
Take a piece of magnesium ribbon.
This is burning of a magnesium ribbon. Do you know about burning of magnesium ribbon? What will form?
Over a flame.
There is a white tab. Yes.
The magnesium ribbon burns with a brilliant
Just
white
a minute.
light.
Tell me. Who is that? Magnesium ribbon. We are discussing about magnesium ribbon. Magnesium ribbon is a type of ribbon with magnesium content, and when it reacts with or when it burns, a white colored ash will be formed. And this white ash indicates the formation of a magnesium oxide, which means this magnesium ribbon, which contains magnesium, and it reacts with the oxygen, the air, that means the oxygen, and it forms its oxide. So when it reacts with its oxygen, it forms its oxide, and this white colored ash, that is called the magnesium oxide. It will be the product.
You will notice a white powdery ash left behind when the magnesium ribbon is completely burnt. Collect.
This is the chemical formula, that is magnesium. Do you know the symbol of magnesium? This is the symbol of magnesium, that is Mg, magnesium, plus O. O2 means, you know, that is molecule of oxygen, 2 moles of oxygen, and which undergo a reaction. What will be the product? Magnesium, this combines with the oxygen. We know that it will burn in presence of oxygen. So the product compound will be magnesium oxide.
Miss, അപ്പൊ ഈ കൊതുക് വീതിയൊക്കെ ഇരുപത് സാധനം
കൊതുക് തിരി
ഇങ്ങനെയല്ലേ കത്തുമ്പോ ചാരം വീഴൂലേ?
അതെ, കൊതുക് തിരി അതുപോലെ, പക്ഷെ അതിന്റെ അകത്ത് പ്രസന്റ് ആയിട്ടുള്ള കണ്ടന്റ് മഗ്നീഷ്യം അല്ല കേട്ടോ. The same reaction is like that. It is also a chemical change. We know കൊതുക് തിരി അല്ലെങ്കിൽ അഗർബത്തീസ് ഒക്കെ burn ചെയ്യുമ്പോൾ എന്താണ്? It is a chemical change occur.
Take the white ash and drop it into a beaker containing 30 ml of water. Stir the water thoroughly and test it with litmus paper. It turns red litmus into blue, while blue litmus does not change the color.
So what do you understand from this? When this ash, magnesium oxide ash, we mix with the water to test whether it is acidic or basic. When we dip a red litmus, it turns to blue. But when we dip a blue litmus, there is no change. What is your observation?
Base.
Yeah, it is a base because it's oxide. The magnesium oxide will be formed contained in the solution, which is acting as a base. It is basic in nature.
You can conclude that magnesium on burning in air forms a new product, that is, magnesium oxide. The change proceeds with the evolution of heat and light. The change is permanent and irreversible. The magnesium oxide is added to another chemical reaction, forming magnesium hydroxide, which is basic in character.
Okay. Then, how this magnesium hydroxide is formed? Here I told you that when magnesium ribbon, it burn in air, in presence of air. Air means which contains oxygen. So when it reacts with the air or oxygen, its oxide, magnesium oxide will be formed. And when we mix this with water, we know the solution. This solution will be basic in nature. You know that in basic, for bases, the most common ion present in that is, what is the ion present in bases? Yeah, hydroxide ion. Yes, hydroxide ion. So you know the chemical formula of water. What is the chemical formula of water?
H2O.
Yes, H2O. So when this magnesium oxide, MgO, magnesium oxide is MgO, that when react with this water, that is H2O, will give what? MgOH. Okay, MgOH is the new product. This is MgOH twice. So this is the new product formed in this solution, that is magnesium hydroxide. Okay, do you understand the reaction? When this oxide reacts with the water.
A beaker is half filled with water. A teaspoon full of copper sulfate is added to it. A few drops of sulfuric acid are now added to the solution. Do you notice that a blue
Okay, before going that, we can read our textbook. Please take page number 59, chemical change. So you underline the sentence about physical change, isn't it? Then now take chemical change, page number 59. A change with which you are quite familiar is the rusting of iron. That is the common example for a chemical change, isn't it? Rusting of iron. Then if you leave a piece of iron in the open for some time, it acquires a film of brownish substance. This substance is called the rust. You know that. And the process is called rusting. Iron gets of parks or farmlands, iron benches kept in lawns and gardens. Almost every article of iron kept in the open gets rusted after a long time. Then at home, you must have seen shovels and spades getting rusted when exposed to the atmosphere for some time. That is about rusting of iron, and I think you all know about it, isn't it? Rusting of iron means when we keep iron for a long time in atmosphere, it reacts with the oxygen and form rust on it. Isn't it? Do you understand? Sri Vishnu, what are you doing there? Are you singing song?
No, miss.
No.
Sir.
Okay. Then, in the kitchen, a wet iron pan or tawa often gets rusted if left in that state for some time. Rust is not iron. It is different from iron on which it gets deposited. Let us consider a few more changes where new substances are formed. So, we say that rusting of iron through which a new product will be formed. And to be activity 6.6, that is the burning of the magnesium. We already see in that video. We can read about that. To be demonstrated by the teacher. That is because it is very dangerous. When burned, what will happen? Heat is evolved, isn't it? During burning, heat and light will be evolved. Some cracking or like that may be occurred. So it is a very dangerous activity, and to look for long at the burning magnesium ribbon. The teacher should advise children not to stare at the burning ribbon. Okay. Then get a small piece of a thin strip. All of you listen to your textbook. Get a small piece of a thin strip or ribbon of magnesium. Clean its tip with a sandpaper. Bring the tip near the candle flame. It burns with a brilliant white light. When it is completely burned, it leaves behind a powdery ash. What is that powdery ash?
MgOH.
Powdery ash is MgOH.
അല്ലേ?
MG.
MgO.
Magnesium oxide.
Yeah, magnesium oxide, not hydroxide. OH is hydroxide because it contains hydride, which means water. The amount of water, content of water is there. So MgO, when it reacts with oxygen, it forms oxide. So MgO. When it is completely burned, it leaves a powdery ash called magnesium oxide. Does the ash look like this magnesium ribbon? Is it yes or no? Does the ash look like a magnesium ribbon?
No.
No. The change can be represented by the following equation. Underline it. That equation is very important. What is the reaction happened there? What's that? Magnesium plus oxygen gives magnesium oxide. O2. O2 is the presence of oxygen. That is 2 molecules of oxygen. We normally say that oxygen which contains 2 molecules and O2. So magnesium plus oxygen which gives magnesium oxide. The equation here are different from those in mathematics. In equations of this kind, then arrow implies becomes. Do you know about that arrow? Magnesium plus oxygen, which means magnesium react with the oxygen. In order to show that reaction, we use the symbol plus. And why we use the symbol arrow? We use that symbol arrow to become means product. It indicates the product to become what to become. That is the arrow indicate. The arrow implies becomes. No attempt should be made to balance chemical equation at this stage. So there, collect the ash and mix it with a small amount of water. This is the another step. That is, when we mix it with a small amount of water, there also another chemical change occurs. Isn't it? That oxide is converted into what? Oxide is converted into
Aqueous solution.
oxide. When we react with mix with the water, the magnesium oxide, that oxide is converted into
MgHO.
not MgHO. The oxide is converted into hydroxide. Hydroxide is not HO. That is OH. That is the formula. The formulas cannot be changed. Okay. OH, hydroxide, not HO. Don't like that. You will have sometimes a confusion. Why we can write magnesium oxide MgO? Why we can't write OMG? Don't think like that. Yeah, what, Joanna? You have You have such a confusion. Okay, don't be confused like that because we only write the chemical name which includes the subnames, that is subgroups are in the second prefix. Okay, which means the magnesium, carbon or hydrogen, like that elements are present. After that, their functional group. All these hydroxides, oxides, all belongs to the functional group. Which group it belongs means. Okay, so only after that we use this. So magnesium hydroxide, that is OH. Hydroxide is OH. The formula of hydroxide is OH. Remember it always. Don't forget. And what about hydrogen ion? Hydrogen ion. The name itself, the symbol.
Hydroxide.
Hydrogen means the symbol is H. Okay, so H plus ion. Only hydrogen ion means H is only there.
H plus ion.
Yeah, H plus ion. Do you know about the periodic table?
No.
No. You don't study about periodic table. So you will be familiar with these elements. It is very important to familiar with these elements. So in the next week class, I will introduce you a periodic table. Okay. The different elements and the symbols for showing different elements. Okay, I will introduce you just to familiarize with the periodic table. We have not enough time because our exam is there, but I will show you. Okay, then please listen. The next paragraph. Collect the ash and mix it with the water. So oxide turns to hydroxide. Then stir the mixture well. Test the mixture with the blue and the red litmus paper. Then we get that it is a acidic or basic.
Base.
Yeah, basic in nature. Does the mixture turns red litmus blue? Question is there. Please answer. Does the mixture turn red litmus to blue? Yes or no?
Red litmus blue out.
Yes. So the answer is yes. Does the mixture turn blue litmus to red?
No.
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 Okay, no. On the basis of this test, how do you classify the aqueous solution acidic or a basic? Then, on dissolving the ash in water, form a new substance. This change can be written as, please underline that change, that is magnesium oxide plus water. Water is H2O, which gives magnesium hydroxide, which is a base. As you have already learned in chapter 5, magnesium hydroxide is a base. Which is base is present in milk of magnesia?
Magnesium hydroxide.
Okay. So magnesium oxide is a new substance formed on burning of magnesium. Magnesium hydroxide is another substance formed by mixing of magnesium with the water. So do you understand about chemical and physical changes? Okay, we will study the remaining topics in the next class because our time is over. So those who didn't finish your notebook, complete your notebook after the class, before next class. Okay. Thank you all.
Bye, miss.
Bye. Bye.